All right, welcome back. It's the second half of the 19 F notes on tangents to curves. Okay, example 9 from page 618 says, find the coordinates of any points on the curve with the equation f of x equals x cubed plus 3x squared minus 9x plus 5, where the tangent is horizontal. Okay, so here's the big thing. When the tangent is horizontal, okay, so that means the slope. So we've got a horizontal line, so that means the slope of this line has to equal 0. The slope of any horizontal line is 0. Okay, so we know the slope, and we have the equation of the function. Okay, so what we want to do now is we know that the slope is 0. So what we're going to do is we're going to find the derivative of this function. And we know that the derivative and the slope are the same thing. So this f prime of x is going to end up equaling 0. All right, so let's just do this. F prime of x. So derivative is 3x, subtract 1, 3x squared. 2 times 3 is 6x, and that's 2 minus 1, so that's just x to the first. There's a 1 here. 1 times negative 9 is negative 9. And then we subtract the 1 there, and that just turns into negative 9. And then remember, the derivative of any constant is just 0. So here's our derivative function. Okay. So the derivative is helping us find the slope of the line, right? But we know that the slope of the line is 0. So that means this 0 right here is going to go in for this f prime of x. So basically we get 0 equals 3x squared plus 6x minus 9. All right, and now it's just back to algebra and advanced algebra stuff when we are just factoring. Okay, so find any common factors that we have in here, which there are some. You can divide all of these by 3, right? So factor 3 out of all of these, and we get, let's see, let's get rid of that. Let's try this again. Okay, so we get 0 equals 3 times, that's x squared plus 2x minus 3. Okay, and now we can just factor this out. Since the leading coefficient now is 1, what are the factors of 3 that have a difference of 2? There's only one set of factors of 3, and that's 1 and 3. Right? This sign here always goes with the bigger of the two, and then this sign tells us that these two signs have to be opposite since it's negative. Okay, so we have to figure out what makes this equation here equal to 0. So it's when either this is 0 or that's 0. So x has to equal 1 or negative 3. Okay, now interesting, there's actually 2 points. There's 2 times when this equation here has a tangent that's horizontal. If you think about it, it's x cubed. So x cubed function looks something like this here, right? And here is one tangent where the slope is 0, and then here's another slope where the tangent equals 0. Okay, so we got to find both those spots. So we got to find this point and this point. All right, so we know that this point here, let's see, we got negative 3 and 1, so this one's farther to the left, so let's call this one negative 3, and we'll call this one 1. Okay, so now we're trying to find these coordinates of the original function, so we're just going to take this negative 3 and plug it into the original function to figure out what the y is, and then we'll also plug the 1 into the original function and figure out what the y value is. All right, so let's do that. We got f of negative 3 is negative 3 cubed plus 3 times negative 3 squared minus 9 times negative 3 plus 5. Okay, so f of negative 3 is negative 3 cubed is negative 27. Negative 3 squared is 9. 9 times 3 is positive 27. Those just turn into 0. Negative 9 times negative 3 is positive 27, and then plus 5. So we get f of negative 3 is 32. So here's 1 point, negative 3, 32. There's 1 point where the tangent is horizontal. Okay, and then we just got to find the other point, which is f of 1. Right, so that's a separate problem here. So we do 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. Okay, so that gives us 1, and 3 times 1 squared is plus 3, minus 9 plus 5. And if you do the math on that there, we get 0. So there's 2 points. It says find the coordinates of any points on the curve with the equation, blah, 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 where the tangent is horizontal. Here's the two points. All right. At these 2 points, the tangent is horizontal. All right. So that's that one. And we have one last problem to do. Example 2b from page 618. Okay. Find the coordinates of the point or points on f of x equals x cubed plus x squared minus 1, where the tangent has a slope of 1. All right. So it already has given us the slope. Okay. So we know that our slope equals 1. So we're going to basically just do the same thing we did on the example before. Okay. So again, we already know the slope. So we are trying to find the equation. Sorry, we're trying to find the points where the tangent curve has a slope of 1. All right. So first thing, let's take the derivative. So f prime of x here is 3x, subtract 1 from there, and we get 3x squared. And then plus 2x. Again, we subtract 1 here, so it's just 2x to the first. And then the derivative of a constant just turns into 0. So there's our derivative. All right. Now, they tell us that the slope here, the slope is going to be 1. So now we take this 1, and we're going to plug it in for this. We're going to substitute in for the f prime of x, because again, the slope is the same thing as the derivative. The slope of the tangent is the same thing as the derivative. So 1 equals 3x squared plus 2x. All right, let's make this thing equal to 0. So we'll subtract 1 from both sides. And we get 0 equals 3x squared plus 2x minus 1. Okay, try to find a common factor. There isn't one. So we've got to factor this thing out. So what we've done in the past is we multiply the first times the last. So let's just ignore the sign for now. So 3 times 1 is 3. We got to come up with the factors of 3 that have a difference of 2. And that comes out pretty nice. So this is where we bring the 3x squared down. We bring the negative 1 down. And we know that we have 1 times 3 is what's going to give us our 3. And we want these both have x's, so 1x and 3x. And we want them to add up to be positive 2. So this has to be negative x. So we'll do 3x squared minus x plus 3x minus 1. Okay, and remember, this is where we group them. Okay, whatever way you want to factor this is fine. If you want to do guess and check, or do the X and box thing, whatever. However you want to factor this, you go right on ahead. This is how we've done it in the past, so I'm just going to stick with this here. Find the common factors of these two, right? Factor the X out of both of these, and we get X times, and we get, let's see, we have 3X left and minus 1. And then these don't have anything in common, so we just factor a 1 out. So plus 1 times 3x minus 1. These two things should match, which they do. So that we're basically factoring a 3x minus 1 out of both of these terms. So we take the 3x minus 1 out. And we have the leftovers. X plus 1 is left over. So this one here, that means x equals, opposite of negative 1 is 1. Divided by 3, 1/3, and then negative 1 plus 1 gives us 0. So these are the two x coordinates of the tangent that has a slope of 1. Okay, so we got to plug 1/3 and negative 1 into our original function to find those 2 points. Okay, so we're going to do f of 1/3 is going to be, we do 1/3 cubed plus 1/3 squared minus 1. Okay. This is going to be pleasant. All right, 1/3 times 1/3 times 1/3 is 1/27. Plus 1/3 times 1/3 is 1/9 minus 1. All right. So when we add this all up together here, 1/27 plus 1/9 minus 1, we just get negative 23/27. Okay. So that means one of our points then has to be 1/3 and negative 23/27. So that's a nice one. And then we'll do the other one, which is f of -1. So we do -1 cubed plus -1 squared minus 1. -1 cubed is -1. -1 squared is 1. And then minus 1, so we get f of -1 is -1. So the other point then is -1, -1. So here's our 2 points that have a slope, that the tangent at these 2 points, the tangent to the equation is 1. All right, so now you should be able to say I can find the equation of a tangent to a curve at a given point, and also I can find horizontal tangents and tangent points to curves. Okay, if you have any questions, please ask. Thanks.